Oracle's Java pricing, as you know, is forcing one of the biggest enterprise migrations we have seen in years. Azul's 2026 State of Java report shows 92% of organizations are now concerned about Oracle's pricing, and 81% are actively migrating to OpenJDK. Not planning, but actively migrating right now. For the past couple of years, this was a discussion, a plan on someone's roadmap. But in 2026, it has become an immediate reality. So, what's changed on the ground that has turned this from a future initiative into a crisis level priority? For the past couple of years, this was a discussion, a plan on someone's roadmap. But in 2026, it has become an immediate reality. So, what has changed on the ground that has turned this from a future initiative into a crisis level priority? That's exactly what we are going to find out in this episode of Java Reloaded with Simon Ritter, Deputy CTO at Azul. Simon, let's start with the report itself. Walk us through what the 2026 State of Java report is, who you surveyed, what you're looking to understand, and what are the key findings that CIOs and engineering leaders need to know about.
Yes. So what we've done is, as a company that focuses on Java runtimes, we thought it would be a good idea to survey the market and find out what our users are actually doing with Java. And so for the last couple of years, we've been running this State of Java survey. We basically survey anybody who's using Java, and that can be right from the C-level executives all the way through to developers. So we're looking at a very broad spectrum of the people who are involved in Java. And then we ask them a sequence of questions to try and derive some information about how Java is being used, whether Java is being successful, how it fits into certain spaces, because of course, being 30 years old now, we've seen that Java has become very embedded in lots of different applications. But is it being used for new things? Specifically, we're looking at how it works in terms of the cloud, people moving typical workloads into the cloud, and we're also looking at how does it relate to the good old AI, which of course everybody likes to talk about at the moment. So yes, we want to see if Java is fitting into that space and how it's fitting into that space. So we're definitely looking at all the different aspects of Java usage.
Excellent, thanks for sharing that. Now let's dig into that Oracle migration number. 92% concerned about pricing, 81% actively migrating to OpenJDK. We have been hearing about this for a couple of years, but this feels like a tipping point. Can you talk about what's happening on the ground in 2026 that has turned this from a plan into an immediate reality for so many customers?
As we know, the reality is that Oracle have changed their licensing, they've also changed their pricing, which has had a really substantial effect on the way that people perceive the cost of Java, because the prices has gone up massively in many cases. The reason that we're still seeing this as being a huge thing for people who are using Java is because it isn't something that, when Oracle made the change to their licensing and their pricing specifically, it wasn't something that was going to impact everybody at that moment in time. So the reality is that people have Oracle contracts which expire, after 1 year, 2 years, 3 years, and so on. And what we're seeing is that continual sort of flow of people where they're hitting the end of their Oracle contract, they're being given a renewal price, and suddenly they're looking at it going, "Ooh, hang on, this is going to be really expensive," and they need to take action to look at alternatives where they can use Java, continue using Java, but do so without having to necessarily pay the price which is being asked by Oracle. There's also a sort of secondary effect that we've seen, which is where some customers have come up for renewal with Oracle, and Oracle have offered them a 1-year extension to their existing contract, but on the same terms and conditions they had before. So they were able to get it at the same reasonable price, if you like, that they had before. But now those 1-year contracts are also expiring, and they're being forced to go on to the new licensing metric, at which point they're obviously looking around and saying, hang on, what can we do to lower our costs, specifically around the Java runtime, and maintaining the level of support that they need so that they can ensure that their applications are getting maximum stability, maximum security. Because if you think about going to a free version, that sounds great because you're not paying anything for it. but it doesn't come without a cost because of the impact of not having maintenance necessarily with a service level agreement and not having a support organization that you can call on if you have a problem. So that's what we're really seeing.
Your data also shows that 62% of enterprises are now leveraging Java for AI functionality. Does this signal that we are moving from the experimental phase where teams were just testing things out to the production phase where Java's scalability is now critical to actually running these models for real business workloads?
Mhm. Yes, exactly. You see, because when you think about AI, most people think of developing applications using Python. That's the most popular language that has been used for developing a lot of these things, and that's very sensible because if you think about the people who've been developing the core parts of AI applications, they're typically data scientists, and what they're looking for is a programming language that's easy to approach. They can use it to create their applications quickly, and they can get things working. So that's all really good, but the issue that we now see is that as people want to move the AI functionality into the enterprise, where they are going to be dealing with these huge amounts of data, the data lakes, as some people like to call it, and we're going to be using or supporting a much larger number of users, then what you're going to need is scalability for those applications. And this is a classic situation that we've seen previously where people have started off using a particular technology because they thought it worked very well for a situation, and then they've discovered as they need to scale to more and more users that Java is the thing that solves that problem. And I think that's what we're seeing with the AI side of things, is that we need to scale up to the large amounts of data, the large number of users, and Java really delivers on that. But again, there's a secondary effect with this, which is the fact that so many of the existing enterprise applications, if you take things like CRM, ERP, accounting, all of the sort of web services that we build in Java, what we're really looking to do is take those existing things, those existing functionality, and add artificial intelligence type functionality to that. So what you're really going to be doing is extending the existing applications and building AI on top of it. That then means that what you really want to do is to continue using Java for that. You've got the developers with the domain experience, the domain knowledge around those things, so they can then add the AI functionality to that and build the things that people actually need to use. So you get a double sort of benefit. One is the scalability, the other is the fact that you can develop the applications and extend the things you've already got.
Your report also shows that nearly 3/4 of organizations have over 20% unused compute capacity. That's essentially waste. And at the same time, cloud costs are under intense scrutiny. How does the choice of Java platform impacts this? Can you give us, if possible, a concrete example of how moving to a high-performance Java runtime translates into actual cost savings or better resource utilization?
Yes. So as you say, the interesting thing that we see from the survey, and this kind of ties into sort of more anecdotal evidence in talking to customers and talking to people at conferences and so on, is that there is a lot of over provisioning in terms of cloud compute resources. And that's an effect which we see where people have typically done a lift and shift of applications. They've taken applications that are running on a data center that they're maintaining, and they just shift that application into the cloud, and suddenly they discover that they're using more resources and it's actually costing them more than if they'd left it in the data center. But even when you move to more of a typical microservices architecture, breaking up your monolith, making it into small individual services, what we're seeing is that because of the time it takes to get those services online, what people are doing is, rather than doing the spin up of those services dynamically and addressing the change in load as it happens, they're saying, well, it's going to take time to spin up a new instance of that service. We don't want that time where we're going to see a dip in performance. So what we'll do is we'll keep one in reserve. So it literally sits there doing nothing until they see a increase in load. Then they bring that online, connect it up, use that, and then they say, okay, load drops off. We'll keep it there because it's hot, it's ready to go. Now, what we can do with a better Java runtime is we can address the issue that people see in terms of getting that service up to speed quickly. Because with Java applications, because they use Java bytecodes, they're interpreted, write once, run anywhere type of approach. That means that there's a warm-up associated with the application. It takes time to go from cold start to getting the maximum level of performance. What we can do with a higher performance Java runtime, such as Platform Prime from Azul, we can let the application start up. We then take a profile of the running application, which includes all the information that we need to know about what to do when we start it up again. And that way, when we start it up again, we can immediately do the things we need to do, and we can get much faster warm-up of the application. But we can go even further than that. And we've got examples of customers we're working with where we have a technology we've developed. It's an open source technology. We've contributed to OpenJDK called Java on CRaC. So Java on CRaC is coordinated restore at checkpoint. And essentially what that does is it says, right, you've got your running application. Why don't we freeze it at a particular point, and then when you want to use it again, you can simply restart it from exactly the same point. The analogy is, you're using your laptop, you have a web browser open, you've got a Word document open. If you want to go on a train and travel somewhere else, what you can do is just close the lid, travel on the train, open up the lid again, and everything's exactly as you left it. What we're doing is the same thing with an application or a microservice. So you can embed into a microservice an image of a running application so that you can start it up from that exact point, and that gives you really lightning fast startup. I mean, to give you, you asked for an example, we did a proof of concept with this using a Spring Boot application, and the time to first transaction for running from cold, just using OpenJDK, was 4 seconds. That was just the time it took on the particular machine we had with that application. If we did a checkpoint and then restored it, so checkpoint restore, coordinated restore at checkpoint, which is what CRaC stands for. If we did a restore, that time dropped to about 40 milliseconds. So we're going 2 orders of magnitude faster. And that's where we can really deliver on the idea of, if you want to bring services online quickly, if you don't have to wait 4 seconds for them to warm up, but you can get them online in 40 milliseconds, then you don't have to keep them in the background, and that way you can reduce your costs associated with running those things and eliminate a lot of that waste.
Let's talk about security. The report highlights something really interesting: CVE noise. Teams are wasting massive amount of time chasing false positives and vulnerabilities in dead code. Why is this technical debt becoming such a critical productivity killer right now? And how should DevOps leader be rethinking this approach to security scanning, and how Azul can help?
This is a good point, you see, because what we're saying is that Java has been around for 30 years, so it's a very successful platform. But the reality that also means is that there are Java applications that have been around for a long time. There are applications out there that have been running for sort of decades. Now, what we see with that is that applications get maintained over time, and a lot of that maintenance involves adding new functionality because usage changes, users have new requirements, and so you take an existing application, give it to your developers, and you say, we need a new feature on there, add a new menu option, add new functionality, and they go, okay, off we go and do that. That's great, but what you also see is that certain things in that application are no longer required. So there'll be aspects of the application that are new, but aspects that are old, and suddenly things are changing and you don't need them anymore. But nobody is really doing the work of saying, okay, well, let's have a look at that application and decide, well, if that feature is not being used anymore, we can actually remove that code from our application. So you add and add and add and add, but you can never delete anything. And that creates a bigger, what we call attack surface, because the number of vulnerabilities that are potentially there can increase. And if you're using library code and so on, then you are going to spend more time looking at the issues around security and ensuring that you've got that maximum level of security. So what you really need is a way to say, okay, let's run our application, but let's find out what code is being used and what code, more importantly, is not being used. And that's what we've done in terms of what we call our code inventory. It's part of our intelligence cloud set of products. And the idea behind that is because we control the Java runtime, and that's both Platform Core and Platform Prime, we can take advantage of the fact that we can build things into the JVM to look at the information that's already collected. big thing there is the class loader. So we can see what classes are being loaded. We can see what methods are actually being used in an application. We can keep a track of that, and we can produce a report. If we do that over a period of time, and that could be, like maybe even 6 months, maybe longer if you really want to, we look at how our application is being used over 6 months, and we can see all the parts of the application that are being used. But then we can invert that, and we can say, well, okay, we know what code is being used, but this is the code of the application. This is all the parts that are not being used. That then gives the developers a real head start, because then they can go back and they can look at that and they can go, yes, so these parts aren't being used. Actually, this code is no longer required in our application because we don't need that functionality anymore. And they can safely delete that, reduce the attack surface, and reduce the amount of time that DevOps teams are having to spend on maintaining the security of that application. So it's a way of improving the efficiency of an existing application, by looking at how to eliminate dead code.
Can you also talk about what is the most widely used version of Java? Are organizations still running unsupported, very, very old versions, which get you worried? Or they are on latest version, the market is mature, so they do understand they're mostly running LTS versions? Because sometimes there are a lot of challenges associated with migrating or upgrading. And if organizations are running older version, what kind of support Azul offers them so they can stay on the latest supported versions?
Yes. So we asked users about which versions of Java they were using. And it was interesting to see that I say obviously, it was what we expected, was that most people are using what are called long-term support versions. That means the ones that still have maintenance and support associated with them. So that's good. It was quite interesting to see the sort of breakdown of that. So if we look at the sort of more recent long-term support versions, JDK 11, 24% people said that they were still using JDK 11. JDK 17 was 26%. The highest one was JDK 21, which was 37%. And that, again, is very logical because you've got a large number of people who are keeping up with the long-term support releases, but maybe not jumping to the newest, so that they allow time for that to, any issues to be resolved before they move to that. So I would very much expect to see people using the previous long-term support release, which is exactly what we had in the report. Interesting as well, JDK 25, which had only just come out when we did the survey, there were 18% of the respondents who said they were using that in production. And that, I think, is a testament to how easy it is to move to newer versions once you've got to sort of the long-term support train, if you like. But looking at sort of the older stuff and unsupported type of applications, that also was interesting. There's still 21% of people in our survey who are using JDK 8, and that's a very old version. Fair enough, you can, there are still updates available to that, but it is an old version of Java. And for very, very old versions, JDK 6 and JDK 7, which are the earliest versions that are open source, we saw 9% of users using JDK 6 still and 11% using JDK 7. And the one thing I would say in terms of what we can offer from Azul is that we are literally the only JDK distribution provider who still provides security patches and bug fixes to JDK 6 and JDK 7. So for those people who are still using those very old versions, we can actually make sure that they do have the maximum level of security and stability to continue running their applications without having to try and upgrade to a newer version.
Let's zoom out for a second, looking at the 2026 landscape between the AI boom, Oracle migration wave, and pressure on cloud cost. If a CIO walks up to you and asks for a single most important strategic move they should make regarding their Java estate this year, what would you tell them?
I think it's to look at how efficiently you're using your resources. And that's, across the cloud and across your applications and so on, because it's all about cost. So if you're the CIO, CTO even, you're going to be looking at how can I reduce my costs. Everybody wants to reduce costs. And so can you make your applications more efficient? Can you reduce the amount of cloud resources you're using to provision the same amount of service? So that's where, like I say, Platform Prime can come in. Can you reduce your load on DevOps by eliminating dead code and therefore reducing the load for security and things like that? So I think that the key thing that the CIO and even CTO has got to be looking at is how to make things more efficient in terms of what they're doing with their Java applications.
Simon, thank you so much for joining me and breaking down what's really driving this massive shift in the Java ecosystem. The combination of pricing pressure, AI workload, and that unused compute capacity is creating a perfect storm for change. And it's clear our organization needs to act now. And thankfully, we have organizations like Azul to help them take that action. Thank you for your time today, and I look forward to our next conversation. Thank you.
Thank you very much.
And for those watching, if you are dealing with Oracle pricing pressure or trying to optimize your Java infrastructure, make sure to check out Azul and his solutions. And don't forget to subscribe, like this video, and share it with your team. Thanks for watching.